3. This is China's Math Olympiad of 2020. It's a problem 7, fill in the blank. Usually it should take less time than some other major problems. Here we're given an equation in square root and absolute value. It's kind of tricky, huh? Here it's constant a, b are positive. We know that the equation has 3 distinct roots. x1, x2, x3. The biggest one is actually equal to b. Okay? And then we try to find what is a plus b. Why don't you try to find it? When you're ready, we can continue with the solution. Actually, we would want to square the equation to get rid of square root. Let's do that. So what you have, when you square it, you're going to have x squared root, and you have x plus a, absolute value, plus 2ab, which is x times x plus a. Yeah? And then equal b squared. Now, what to do next? Not easy. Wrong direction. All right? So here, the trick here is to try to use variable substitution to turn this equation into an equation with a special property. Notice that we're given the 3 distinct roots, and then here what we do is original equation, let's write it here, x absolute value, x plus a absolute value equal b. All right, so when you do this variable substitution, the function in u becomes this one. This is much better. Why? This is a function that is symmetric, is an even function. In other words, if we define fu of this, it's easy to find that fu is even. In other words, elective u and u have the same value. All right, so you can easily verify that, right? Because absolute value, yeah, you can plug in negative u, is going to be the same, it's symmetric. All right, now given that there are 3 roots, okay, so even function has a property that if x is a root, negative x is also a root. It's a 3 root string, which means 0 must be the root. Otherwise, roots always in pairs, right? Except for 0, you know, negative 0 is 0. So f0 must satisfy this equation here. If we plug in, we have a over 2 equal b. In other words, 2a over 2 equal b here. Left hand side is equal square root of 2a. All right, that's good. We know they are related like this. All right, so here the trick here is that have the variable substitution, the equation becomes this new equation, which is, you know, symmetric in u, and we claim that 0 is a root because we're given that there are 3 roots. Then we have this relationship here, right? So that this equation here is equal to square root of 2a. Yeah. So we also notice that we're given that x3 is a root and it's equal to b. In this new variable, of course, u equal x plus 2a, since originally b is a solution, in this function in u, b plus a over 2 must be a solution. That's good. Let's plug in the equation here, right? So what do we get? We get u minus 2a absolute value, in this case would be b is positive, okay, plus here u plus half of a, which is b plus a, and b plus a, we want get rid of a, right? Because you know this equation here, if you square it, b squared would equal 2a. In other words, a, b plus a, right? A is equal b squared over 2 equal b. That's good. B is a positive number, so we can divide it by square root of b on both sides. What you get is 1 plus yeah, 1 plus b over 2 equal square root of b. All right. Of course, what you do here is you move this to the right hand side. Yeah, do some algebra multiplication. You square it. 2 here, this is b minus 2 square root of b plus 1. And then here 1 cancels. And here b and half b, you're going to have half of b, yeah, equal 2 square root of b. Again, this is positive, so divide by square root of b on both sides. What you get is 2 equals square root of b over 2. So b is 16, right? What is a? A is half of b squared, right? b squared, 256, half a would equal to 128. A plus b is 144. That would be the answer. Okay. So the key here is the linear transformation here, right? Of course, if you do not use this fact, if you start just purely from this analysis of the problem, you can also derive, the answer. Okay. Alternative method is just for your reference, is presented here, but I won't recommend it. But what you do here is you just start from this equation here, yeah, and since we're trying to solve for u, right, and a is a constant, here every term has a, so it's good to have another substitution, u equal ta, so that we can get rid of the a here. If you plug in, what you get is ta minus a over 2 plus ta plus a over 2 equals square root of 2a. Now you can get rid of square root of a on both sides. What you get is t minus 1/2 plus t plus 1/2 equals square root of 2, because you try to cancel a everywhere, right? So in other words, we become a function in t. How to solve this function here? Use some trick here. You don't want to square it, okay? Here you notice that there's a t, you try to cancel. So this is another common trick in algebra. So let's assume this is a, this term is b. You notice that a squared minus b squared is going to have t cancels, yeah, minus t minus 1/2. That's equal to 1. Of course, we know that that is actually equal to a minus b times a plus b. A plus b here is square root of 2. So what you get is a minus b equal 1 over square root of 2, which is this one, right? Now here of course we know that a plus b equals square root of 2. So what is a? A is gonna be added up, divided by 2, which is 3 over 4 square root of 2. So, and then you solve for t, right? So t plus 1/2 equal a squared would equal to 9 over 16 times 2. So t is 5/8. All right. So if you consider the other case, you can derive that u equals 0. I skip the steps. You can use am, gm property here to make the argument, right? So this one, and this is like a plus must be greater or equal to 2 square root of, this is a 2, yeah, square minus u square, yeah, and it's gonna be it has to be greater or equal to square root of 2a, yeah. You can figure it out later. So u has to be 0. In summary, if you use this approach, later you're gonna say that x3 is actually equal to b, and then you solve for a and b. Of course, the earlier method is much simpler, and these two will give you the same answer, a plus b equal 144. So in both cases, we're going to use some tricks like substitution, or how to deal with square root, in the case of solving this type of problem, right? Or in this case, right? This is a very commonly used tricks also. Okay, hope you enjoy the video, and please like if you do like, share and subscribe to the channel. Thank you.